Hello. I got this thing basically almost totally finished, at least on the assembly. The right earpiece bottom is gluing up, and the antenna stem is gluing up to at the top of the antenna. So these guys got to sit right now and cure, but essentially all this left is like I'm gonna pop this guy on here. I did glue this up, but then as I was like holding it and kind of rolling it in my hand, I realized that it was like not fitted very well. So I actually gotta like remove some of this edge and remove some of this edge, or maybe actually I could remove some of the inside of this with this little tiny guy. Just just get in here and kind of round away that corner so that this sits down firmly in there and doesn't have this it shouldn't be able to rock. It should be like sitting down perfectly flat like a pancake. So the last thing I got to do, I'm going to glue this in here, and I'm not going to pick this up right now, but this little peg goes in this hole, and then this goes over the top of here and gets glued to this, but does not get glued to the top of the lobe here, so that the idea is once this thing is closed, the antenna can ride in this groove and still pivot. It actually like pivots from up, and you can pivot it down. I think it's supposed to be like a sight or a targeting optic that hangs out here in front of the visor. So anyway, that's the last thing that I have to do, and then we'll have our first helmet fully assembled. I also have started printing the parts to do another one. So basically what I started to think about this morning, let's say, okay, I'm gonna assemble all this, and then we gotta like sand it and fill it and paint it and probably sand it again and paint it some more, etc., etc. Let's say I take this piece and I glue this piece on here. Okay. How am I gonna get paint inside, basically like on this surface? Now maybe I can with a long, like a pokey paintbrush, or maybe you could even like get a paintbrush and get the handle like hot and kind of bend it, and there's like creative ways how we could get some paint up in there to basically there's two things you got to think about whenever we're thinking about painting this helmet. First of all, I'm not going to do the cosmetic paint job because I'm not good like that. Where I work, there's other people that can do stuff like that, and I'm probably going to, once we get this totally assembled and filled out and looking nice, I'm probably going to hand it off to somebody that can do some like legitimate art on it that's more visually appealing. But I want to present it to them already being having like the layer lines remedied and like all this. You can see this like lamination where it was just because like the way how the part was turned in the printer, it like left these artifacts across the surface. Like that's not really supposed to look like that. It's supposed to kind of be like flat, like if it was a flat piece of machined metal. Same thing here. It's like you can see like it almost looks like wood grain. That's not good. That should be like one solid piece of like machined metal that have the appearance. So when I'm thinking about stuff like this, I'm like, first of all, you could like rattle can, you could just hit all of this from different angles, like arc it this way, little tiny light coat, then stand off here from this angle and arc it this way, and then let that dry little light coat, and then come and stand off at this angle and run the arc. Like realistically, if we were going to just rattle can the whole thing, like you can kind of get paint in some unusual secluded areas just because of the nature of like there's like particles that are suspended in air that are kind of like going to get places. But the thing is, with these grain lines like that, what's really nice is if we could use a little paintbrush, because that little paintbrush is going to do better at actually like packing the paint down into the grooves between those lines of filament. So something like this, like basically like presents a unique issue where like it's going to be different. Now, obviously, you got to look at this from a couple different aspects. Like, I'm pretty sure that this first assembly, or maybe even the first two assemblies that I'm putting together right now, they're basically going to sit in like a shadow box and be like a nice thing to look at on the wall. So is anybody going to be looking up inside this hole to see if I got like enough paint in the right places? Like, probably not. That sounds kind of dumb. It sounds like that's probably not ever going to happen. But this is a great example of the types of issues that arise when you're manufacturing something. Is like, okay, it could be more beneficial on the next run. Like, once I've kind of worked out some of this in my mind, it could have been more beneficial that as part of the assembly process, this piece actually gets, maybe we sand and paint this piece before we glue it on. Obviously, you wouldn't want to paint the surface that you're going to glue. That would be like the wrong order of operations. Like, we want the glue applied directly to this plastic surface. But like, for instance, like this surface, it's not going to get any glue on it. It's just hanging right here, not touching nothing. So like, as we do stuff like this, as we like go through the motions of learning a new thing, it's just by the nature of, I guess, like how your brain works. Like, you're going to pick up new things that would have made it better if you would did it differently. Like, we already identified like this seam on the side of the helmet. We should have located that seam right in the middle of where this earpiece goes, because then this earpiece covers the seam so we don't have to feather the seam at all, because it'll just be covered by this piece. And also, this piece acts like a Band-Aid that glues the front half to the back half, and we're not just depending on the strength of the glue in this tiny little crack. So like, as we go through this and do this more and get better at it, we will get better at it. We'll like identify issues that we hadn't even thought of before, like painting, applying the paint to one little surface of a part before it gets installed. And in reality, that might not be the best example, just because, kind of like I said, it's kind of a negligible issue that's not, I don't know if it's really going to be worth the amount of resources that would be required to make sure every single surface gets a perfect treatment. You know what I mean? Like, we got to economize our time and our effort where it's going to be most valuable, and maybe making sure that I get the right amount of treatment on this surface is not like the most valuable thing that we could do with our time. But long story short, I got to thinking we probably should print up another round of parts. And first of all, because that way, if we break this one painting it or filling it, that way we have another one. Also, like, two heads are better than one. Maybe I could put one of these on display here at work and take one at home and put one on display at home. I don't know, but I know that probably we probably should print another one, since, especially too, it's proof of concept, because like, what I want to say now, most likely, if my thinking is correct, is that like, we have all the kinks worked out on all the part files, so that I should be able to print every piece to this helmet in one shot and get it right on the first shot. This is the first piece that I printed. It's the rear detail that goes back here on the back of the helmet. It's sitting right there. I got my earpiece printing. I'm trying to use up some of these filaments too. I got like enough filament on these rolls to still do some damage, but the size of the filament has like gotten smaller than the little sight glass. See, they got like a little estimator on here for how much filament you got left, and you can see like it's less than I can like measure. So unfortunately, like, when I'm going to print a big part, like some of the parts for the dome, for the like the top shell of the helmet, like I think like the back left part, one of these is like 7.5 hours long. So that's a really long print that uses a lot of plastic, and I don't want to send a large print on one of these rolls that's like kind of running out, or not running out, but I can't accurately estimate how much there is, and then like it prints the whole part, and then it runs out of filament in the last 30 minutes and the part's ruined. So it's like basically I'm gonna use this roll that I can still see the numbers on to do big parts, like that 7.5 hour jobber. And then this one over here, this is printing the 2-3 hours tops part, because just from doing this as long as I have, I know I probably got at least like a 3-hour print in there. But long story short, so that's I was like, kill two birds with one stone. We'll get some more parts coming through. We'll get some more experience with assembly and finishing and that kind of stuff, because that's honestly something that I have like basically very little experience with. I've been playing with the 3D printers for a long time, but a lot of the stuff that I've done with 3D printers has been like little like functional, practical stuff, like a bushing or a bracket or a spacer or a like a jig for drilling a hole in the right spot on something. Like I've basically done like a lot of like I don't know, like small, like mechanical kind of stuff. So this is my first like big, aesthetically pleasing thing, the kind of more artistic thing that I've really ventured into. I did do a 3D model of a Fairbairn Sykes dagger, based off of old technical drawing that I found on the internet. That's pretty cool. I'll probably like upload that or something at some point, but I mean, there's not much to it. It's just a cool thing that I designed or whatever. But this is kind of my first step into like doing physical, artistic kind of cosplay or whatever you want to call it. So probably get some more hands-on with that. Use up the rest of this filament that I got on these rolls. Have an extra helmet laying around to do more work with, show off or do whatever with. I am probably going to circle back at some point and see about printing another helmet at 100% infill. This was the very first part that I printed here in this project. It is printed with 100% infill. It is like noticeably like more heavy than the ones that I printed with 20% infill. This whole helmet is basically got 20% infill with 2 perimeters, which basically means like the wall is like 2 layers thick and then the infill is in there 20%. So, it would be really cool to run a whole helmet at 100%, just to kind of get a feel for how heavy it is and how much we increase the structural integrity of it. Another thing to think about that's kind of cool, I got a new toy. This is a plastic welder. So basically what this guy does, you stick one of these staples in the end of these tubes. You like put one little leg down that hole, one little leg down this hole. You plug it in the wall, pull the trigger. It basically like creates a short circuit where the staple is like the filament, like in an old light bulb. Like the staple like glows red because this is like making a short across these 2 probes. And then like while the staple's glowing red, you like sink it down into the plastic. It's like melting its way into the plastic, and then you retract your gun. The staple stays in the plastic, and then you get clippers and you like clip off the legs so that the staple stays inside, like the wiggly part stays inside, but like the legs that was holding it in the gun get cut off or snapped off. And it's a way to like basically increase the structural bond between 2 plastic parts. So like, let's say I like print this whole helmet with 100% infill. Well, like that's going to make it a lot stronger. But then if I glue the whole thing together with super glue, really the whole helmet only has the structural integrity of super glue, because like chain's only as strong as its weakest link. And like if I take a bunch of like really strong parts and bind them together with something that's like kind of brittle, or like even just maybe it's not brittle, but for whatever reason it's like less strong than the other parts, the strength that they have basically becomes invalidated, because that weak component that's holding them all together is weak and will fail. So I was thinking maybe, we'll get in here, we'll glue one together, with super glue, just so it'll like hold together, so we can have something like physically to manipulate, and it'll like, you know, we won't have a hard time lining the joints up perfectly. And then maybe come in here with some of these staples and like staple join some of these parts together, so that there's like some more structural bond between this part and that part. And then I even got to thinking, man, you really could probably even take one of these after it's all glued together, and you know, it's ready to be finished. You could probably paint this whole thing with that fiberglass stuff they make canoes out of, man. Because I watched a video not that long ago of this guy who built a canoe out of little like maybe like 1/2 inch by 1 inch, maybe like 1.5, maybe like 1/2 inch thick by 1.5 inch strips of wood, like just tiny little planks of wood, like back in the day, like behind plasterboard. I guess maybe it's called lath. I can't remember. I don't know exactly what they're called, but like just little like tiny little boo-boo, like you get at a yardstick. Like if grandma got a yardstick propped up in the corner, like basically like what those are. And like this dude like made a whole canoe just by like bending these long like yardsticks, like strips of wood. And then once he got it all like tied together and clamped together in the shape of a canoe, he like put a sheet, like a big sheet of fiberglass over the frame he had built, and he painted the sheet with this like fiberglass epoxy stuff, like if you was gonna, you know, do a repair on a car or something like that. Like I was thinking, like, man, we could probably get the structural integrity of these helmets like pretty crazy if we're printing 100% infill and stapling the seams together and lining up these earpieces along the seams, and then taking a sheet of fiberglass and fiberglassing the whole helmet as one monolithic piece. And you could probably even fiberglass the inside, you know what I mean? So I don't know how crazy necessarily we're going to get with all this, but as of right now, I think this is a really productive thing to kind of like teach people cool stuff. It gives me an opportunity to use some of the equipment up here for more extensive stuff than I ended up using for a lot of time at work. A lot of times at work, I'm doing like more the little mechanical functional stuff, printing a little spacer or printing a little bushing or something. So long story short, I think that'll be fun. We could maybe kind of run a little experiment and see how strong can we get the 3D printed helmet. You know, if we go with the best material, the best staples, we fiberglass it, we you know, whatever. Can we get this helmet up to a point where it's actually offering some level of physical protection, like a riot gear type stuff? I don't know. We'll look into that and see. We can do some informal testing. Definitely the filament we're using, the PLA Plus, PLA Pro, whatever it is, it's great filament. I really like using it. It is like, so far, a lot of stuff I've printed in it has really held up pretty good. But one thing I have not done really is I have not given it the dashboard test. So I live in Texas. I have 3D printed some little knickknacks before, and then unfortunately forgot them on the dashboard of my truck, and they end up looking kind of like a Pablo Picasso. Like a lot of times the thing will still be intact essentially, but it's kind of like melted or deformed, warped. So I haven't really subjected a lot of the PLA Pro to the extreme temperatures yet to kind of see how well it fares. I'm gonna guess probably not very well, because it prints at a pretty low temperature, so it's, you know, it's gonna get flexible at a pretty low temperature. But you know, we get this going pretty good, and we get pretty effective at snapping these together, and it's pretty painless. Like, you know, I might spring for a single roll of some PETG or whatever. You know, we can get on the internets and figure out what's going to be the most advantageous thing to try, or things to try. These printers, I got a couple of these that we can use, but I don't know. They don't have the all metal hot ends. I know that that's an aftermarket thing that people are putting in these, so they can print like hotter filaments, like the glass filled nylon and the carbon fiber filled nylon. I don't know if I'm going to get that crazy with it, just because the cost, it's a little cost prohibitive, and I got to make additional modifications to these machines that's not really totally necessary. And I'd have to like figure out a better filament solution, because when you print like glass filled nylon and carbon fiber filled nylon, like you got to have like a filament dryer. You can't just have your filament like sitting on the table like this, because it absorbs moisture. So like there's some additional logistical obstacles to get over if like when you want to go like really strong, like real like impact resistant and heat resistant and all that. But long story short, we're making good progress on this, and I'm feeling good about it, and I hope y'all are enjoying, the people that are still with us, still sticking around or whatever. And yeah, so this was kind of a long one, but I covered a bunch of different stuff, and yeah, I'll be back in here on Monday to do some more things. All right, thanks everybody. Bye.